engineer, and it's my second year in robotics. Today, me and Jack will be walking you guys through the basic design process. Introduce yourself.
Hi, I'm Jack. I'm a senior. This is my fourth year doing robotics. Started as a freshman. So design process is really important. We use it every single year in every single thing we do. You can narrow it down to individual subsystems, individual pieces of subsystems, to the entire robot. It's really useful. It's really important. I guess there will be some big words and vocab and stuff. You guys don't need to know that. Just understand the basic principles of it.
To start, we're gonna do a fun little activity, and I'm gonna need you guys to either get in groups of 2, 3, 4, doesn't matter, by yourself, doesn't matter. So take a minute to do that, and go to the next slide. Like we're making some paper airplanes, but you only get to do them from your memory. You don't get to use computers, you don't get to use outside resources. You don't want anyone looking them up. So please pass out some papers.
But it should go slower. Huh? It should go slower. Yes. Are you
What's the design process, right? And as I see the picture, it's actually a circle. And when you usually say the word process, you might think of a concept from point A to point B because it's a process. But the design process is actually a circle. It loops back to itself. That's why, because when you engineer a solution to a problem, you're probably not gonna get the optimal solution first try. So that's when you take your prototype, you test it, you figure out what's wrong with it, and then you make another iteration. In robotics here, we keep making these iterations until we get a competition-ready robot. Step 1 of the design process is emphasize, or identifying the problem. In this step, you're gonna make sure to identify what exactly is the problem your design is trying to solve. In terms of FRC robotics competition, our problem that we're trying to solve is to come up with a robot that can win points, that can win the match against other schools. So every year, we're gonna have a kickoff. That's when they announce the game of the year. We're gonna study the game, we're gonna look through the rule book, see what constraints we have. So these are all our problems that we're trying to solve. Once we have that, we can move on to step 2, which is define. Here we get a little bit more defined. We start looking at specific criteria that our designs need to have. For example, we use a tool called wish, prefer, and demand list. A wish, prefer, demand list is basically 3 tiers from demand, prefer, to wish. Demand, as the name suggests, are things that the robot must have. For example, it must be consistent scoring. Prefer, not as necessity as demand, but still, it's nice to have. For example, we want a robot that preferably drives good. And lastly, we have wish. These are like the cherries on the top. We want to have the robot look good, look presentable, look cool. And once we have that, we move on to step 3. Step 3 is ideate. So in the ideate step, we are going to take what we came up with from the previous step, our wish, preferred, demand list, and conceptualize those designs into, for example, we use the CADing software here to actually 3D model the design onto our computers, so we can visualize the designs and come up with the details. For example, if you were to build a drivetrain system, once you have the criteria, this step, you're going to CAD out the actual drivetrain for manufacturing. So now I'm going to send it off to Jack, who's going to walk you through the rest of the design process.
Okay, so by the end of step 3, ideate's a big word. It's just coming up with a design, brainstorming general pieces and whatnot. Step 4 is to begin designing your actual parts in CAD, like Yvonne suggested, or taught you guys about a bit earlier. By the end of this, you should have a very vague design. You don't have to have specific measurements or a really super complex working 3D model of your system. But you should have a general design that's easy to present to somebody who is probably a senior or somebody who's done robotics for a long time. You can go over and look at your design, your idea, and they'll say whether it's good competition. And then from there, we move on to step 5. Step 5 is prototyping. This is when we actually start doing our detailed 3D modeling of all of our parts, and this will also go towards the actual construction of the prototype. Normally we don't have like an actual prototype robot. We prototype subsystems separately, but we'll get to that once the season actually starts. By the end of step 5, you should have a mock-up that is as close as possible to what the actual finished product will be. There's no point in testing a system that's nowhere near what the actual design is. So for step 6, which is the test of your prototype, like here, it's a pretty good example. It's not from our team, but it's a very nice, very detailed mock-up of what their intake system would be for one of the games. I don't think that's last year's game.
2019.
Was it?
2019.
2019? Game before any of us were here on their live team, Souls knows all the games by heart. So you can see it's very detailed. It has everything from their motors, their specific wheels they want to use, all of these very accurate and finely tuned details, and they're testing it in a very simple situation, which is really good. When we're testing any system, we want it to be as similar to the situation as the actual robot is going to be in during the games, but we also want to limit the amount of variables, so you know, we don't we can pinpoint exactly what went wrong if something does go wrong. I guess a good example of that would be if you're running all systems on your robot and something totally breaks, your robot shatters. Good luck figuring out what went wrong. So that's normally the final step. However, when your test pretty much inevitably fails, we have to start the whole thing over with a few modifications. So instead of researching and designing and coming up with and prototyping all this just a completely different system, we generally want to research and modify the system that we already have. It's time efficient. You'll have a pretty more, significantly more refined system doing it that way, and you can go and perfecting little details if you have time as the build season goes on. So by competition, we should have a very nice, very refined robot that should be working at maximum efficiency. So, with that all being said, let's go remake those airplanes. Now you have access to the wealth of knowledge that we've bestowed upon you. You can also use the internet to research, you can prototype, do whatever. Use all the information, make the best airplane you can.